Howdy folks, Mr. K here with the lesson on the states of matter. Now before we talk about the states of matter, there's some vocab you need to understand. First thing is there's something called the kinetic theory, which means that the kinetic theory states that atoms are moving all of the time. Whether it's a brick or the cells in your body or the air around us, everything has atoms and those atoms are moving all of the time. You also need to remember, probably from 8th grade, the two types of energy, the two major types. Potential energy, which is stored energy. It's the something that has energy stored up, so it has the ability to do something. Kinetic energy is movement energy. So, and it's very important to understand that just like matter is conserved, you can't create or destroy matter. You can't create or destroy energy. Energy moves. It can be converted between different sources without being destroyed. This often occurs with the conversion between potential and kinetic energy. For example, let's say you're standing at the top of a hill. And at the top of this hill, you have a high amount of potential energy. And let's say somebody comes along, some mean person, they kick you down the hill, and you start tumbling down the hill. Well, during your tumble, all of this potential energy has been converted into kinetic energy, movement energy. As you're falling down the hill, you don't have any more potential, you have kinetic energy. And you keep tumbling all the way down until you hit the ground. Well, now you're laying on the ground again. All this kinetic energy has been converted back into potential energy at the bottom of the hill. That's how the conversions of energy work. Now, one important thing to understand that's maybe new to you is that whenever you're taking the temperature of something, you're measuring the average kinetic energy of the atoms within that substance. Because remember, atoms are moving all the time. Kinetic energy is the energy of movement. So when you take the temperature of something, what you're measuring is the average kinetic energy of the atoms moving in something. So let's take a look at the states of matter and see how temperature, potential, and kinetic energy relate to one another. So let's start with the first state of matter that you can see all the time around you, the solid state. Solids have atoms that are tightly packed together, or particles tightly packed together. But remember, kinetic theory states that these atoms are moving all the time. There's still movement even within this solid. So they're jiggling around. Solids have a definite shape and a definite volume. You can easily see the volume, easily see the shape. So these atoms are always moving, but they don't have a lot of room to move, so they have a pretty low kinetic energy. But since they have a low kinetic energy, on the other side, the flip side of the coin, they also have high potential. Remember, energy is converted. If you got low kinetic energy, then you would have high potential energy. So this solid has the energy stored to do something. Now let's say we start heating it up, we start melting it. Remember, temperature is a measure of average kinetic energy, so we're adding kinetic energy. And as we melt it, by adding kinetic energy, it becomes a liquid. And the atoms kind of move apart from one another. They're starting to get a little space to move around. The properties of a liquid is that they have no definite shape. They take the shape of whatever you put them in. But they do have a definite volume that you can measure easily. So as we heated up that solid, some of its potential energy was converted into kinetic energy. So you just heated up some ice. That ice lost some of its potential to become kinetic energy. It traded it. So liquids have about a medium amount of potential and a medium amount of kinetic. Well, let's keep heating it up. Let's make the water boil. So we make the water boil and it becomes a gas. Gases have a lot of kinetic energy. They're flying everywhere. They're bouncing off each other. Gases very high kinetic energy, a lot of space between them. Since gases have a lot of space, they have no definite shape and no definite volume. And since at this point all that potential energy in the solid is almost gone, so it's lost a lot of its potential and it's converted that into kinetic. Remember, temperature is a measure of average kinetic energy. So as we heat something up, we add more and more kinetic energy to it. We transfer the potential energy in a solid to become kinetic energy in a gas. If you started cooling something down, you're going to take away its kinetic energy. You're going to go in the opposite direction, convert it to potential. So when we cool down a gas, we call it condensing. So you can condense a gas into a liquid, convert some of that kinetic energy in a gas to potential energy in a liquid. And then you can cool it down even more or freeze it to become a solid again. So you convert all that kinetic energy in the gas back to potential energy in the solid state. Now, we often make graphs in science. That's how we display our data. We like to display data of something called a heating curve. And this is an example heating curve of water. It shows a change in temperature over time as you heat something up. So, notice that whenever you have a phase change, the temperature is not changing. Because during a phase change, either melting, freezing, boiling, condensing, the energy is not being used to make the particles move. The kinetic energy is being used to push the molecules apart from each other. Because remember, a solid's tightly packed together, liquid's a little bit looser, and gas is really far apart. So during a phase change, what the energy is doing is it's being used to push all of these atoms and molecules and particles apart. But when you have a pure substance, a pure phase, like the liquid water phase, all the energy is being put into raising the temperature until it has enough kinetic energy to push the molecules apart in a phase change. So the parts of a graph or a heating curve are the bottom left slant is the solid state. That's where you're heating a solid. Then the first plateau or flat part is the phase change where you're melting or could be freezing, depending on the direction, the solid water. Once it's fully melted, it becomes a liquid. In this slant you're heating up a liquid. And then once it has enough energy, it starts pushing the liquid particles apart during the boiling to become a gas, water vapor. And then that can be heated up even further. And that, folks, is the explanation of heating curves and the states of matter. I will see you in class.